My name is Omar Ataway and I'm going to be explaining a past IB Chemistry Topic 3 Paper 2 question. So in this question it says that it's about the compounds of some period 3 elements, and in part 8 it says state the equations for the reactions of sodium oxide with water and phosphorus oxide with water. Now I'm gonna do the first part, which is sodium oxide with water. Now you should memorize this, and it's advised to memorize this. You should have these equations memorized and you should be able to write them right away on the exam. However, I'm going to be teaching you how to find sodium oxide with water, because it's very easy to find and it will help you with memorizing it, and also help you if you're stuck on an exam, maybe you don't remember a part or something. So I'm going to help you know how to solve it or deduce it so you can memorize it easier. So sodium oxide is a molecule of the elements Na and O. Na is sodium and O is oxygen, and we know that Na is in group 1 of the periodic table, so it's going to want to lose one electron to become stable, or to have an electron configuration isoelectronic to a noble gas. However, oxygen is in group 16, so if it's in group 16 it wants to gain 2 electrons in order to become stable, so it's going to have a charge of 2 negative. So Na is going to have a charge of plus, and O is going to have a charge of 2 negative, and you're going to crisscross and you're going to find that Na2O is sodium oxide. So Na2O is going to be a solid, and you're going to add that to H2O. H2O is just water, it's very easy to memorize. It's going to, of course, have L, because L is liquid and this is a water. And these represent the state of the equation. And they're going to form 2 NaOH. So Na with OH, and it's going to have a 2 here because it has to be balanced. So Na is going to have 2 times Na, you're going to have 2 Nas here, and here we have 2 Nas. And you're going to have 2 oxygens here, because 2 times O is going to equal 2 oxygens, and here we also have 2 oxygens total. And we're going to have 2 H's here, and we have 2 H's here. And it's going to form an aqueous solution because it's a solid with a liquid. Now this is for the reaction of phosphorus oxide with water. And you have to also have this memorized really well. And this is a complex equation, so it's going to be hard to deduce. So you just have to memorize it really well. IB also accepts other forms of these equations. However, the other forms are more complicated in my opinion. So I just advise on memorizing these, and don't memorize any others because they could confuse on the exam. And the BI of the question says, explain why the melting point of phosphorus oxide is lower than that of sodium oxide in terms of their bonding and structure. Now, of course, sodium oxide is going to have a higher boiling point, actually a lot higher than boiling point than phosphorus oxide, and the reason for this is because sodium is an alkali metal. It's in this side of the periodic table, while oxygen is on the other side of the periodic table, and it's going to be a non-metal. And we know that a metal and a non-metal, when they react together, or when they're in a compound together, they're gonna be ionic. Also, another way you can just know that is if something is on this end of the periodic table and something is on the other end, like they're very far apart, then they're automatically just an ionic compound. And an ionic compound, it has a lattice structure. A lattice structure is very rigid, and the electrons are very fixed in their positions, and it's a very strong structure. And it's very hard, it requires a lot of energy to break this structure down. Thus, the boiling point for any ionic compound is very high. However, phosphorus oxide is covalent. How did I figure this out? P is here, which is in group 5, and oxygen is in group 16. And P is in group 15, I mean. So they're very close together. And we know that phosphorus is a non-metal. Oxygen is also a non-metal. And they're very close on the periodic table. Anything that's very close like this on the periodic table is probably a covalent compound. However, you have to confirm from knowing if they're a metal or not. This is a non-metal and this is a non-metal. A non-metal with a non-metal is a covalent compound. And covalent compounds have weak intermolecular forces between the molecules, and the intermolecular forces require a lot less energy to break than a lattice structure. So if they require a lot less energy to break, then they would also require a lower boiling point. And the last part of the question, which is BI, says predict whether phosphorus oxide and sodium oxide conduct electricity in their solid and molten states. And says complete these boxes with yes or no. So phosphorus oxide is a covalent, and since it's a covalent, it's not going to conduct electricity in the solid state. How do we know that? So covalent compounds are compounds in which electrons are being shared. And if electrons are being shared, this means that all electrons are shared with the bonds. Thus, there are no free charged electrons to conduct electricity. And this is the same case for a molten state, because in a molten state, the covalent compounds are still intact, so the electrons are still being shared. The only difference is that in a molten state, the intermolecular forces are broken. However, the covalent bonds are still intact. Thus, even a molten state, there are no free charged electrons. However, sodium oxide is a ionic compound with a lattice structure. In lattice structure, the electrons are fixed in their positions and it's very rigid. So there are no freely moving electrons in a solid state of the ionic compound. Thus, it cannot conduct electricity. However, in a molten state, the ionic compound can conduct electricity, and the reason for this is because the lattice structure is broken down, so the electrons can move freely. So it can conduct electricity when it's in its molten state. And this is the explanation for this question.